Just another quick video. So my last video we did some capacity testing with the iCharger. We were testing some EV modules and we were using the 4mm bullet 12 gauge cable with Anderson power poles. And these cables, or these connectors, they're 40 amp version. Great, super convenient, genderless, which allows you to plug anything into anything. But they were getting a bit hot. And I'll put a snippet in from the previous video here. That's hot. So outside of the housing is 144. Inside of the connector is 167. And it was getting a bit warm. So what we ended up doing is we made some custom cables. We're using an XT 150 connector, and this is all soldered with a TS 100 soldering iron. Very powerful little DC iron running at 24 volts. And we have some 4mm bullets installed here. So basically we have a custom cable, and this is specifically to use with the iCharger in synchronous mode. So we're going to get these things connected up. So in addition to this cable that we improved, we crimped up some 8 AWG silicone leads with ring terminals here, and that's going into the battery. And this thing is going to get the full whack this time from the charger. So let's go ahead and get this thing set up and see what happens. One more quick thing that changed in addition to this cable that we made up. We modified the little breaker setup here. So previously we were running off a 40 amp breaker. We now have a 10 AWG with silicone coming off a 63 amp breaker. And we'll use that. And hopefully this is all going to work out a little bit better and the current handling is improved. Okay, so before we can use our new cable with a XT 150 connector in synchronous mode, which basically means that we're utilizing both channels in the front of the charger for one battery. And if we're doing that, we have to make sure that the charger is set up for two things. Regen, because we're sending it all back to a battery input, so we need to change the power supply, and we also need to make sure that the channel and the charger is aware that we're operating in synchronous mode. So what we want to do is, the first thing is we go into the setup and we want to check the power supply. So here we have the option, and this is an iCharger 4010 Duo. It's going to be similar on other models, but this is what I got. It's going to be X6, X8, all have a similar menu function like this. So you either have to select DC power supply, which is going to be a power brick, like a server power supply, which many people use, and you can put some, settings in there for that, or you have to select battery power supply. So we select battery power supply, and then we go to settings. And we want to confirm we're using a 6S setup. So we want to check our, minimum voltage. So 18. So that's going to give us minimum 3 volts per cell. A current limit. Since we did a breaker upgrade, we're going to go ahead and bump that up to 50. Still a little conservative, but I'm fused at 50 amps, 25 amps per battery. And regen is going to be enabled. So regen allows us to send it back to the input. We have a regen voltage limit, regen current limit, and we're going to bump that back up to 50 as well. And we're going to hit save. We're going to hit save again. So now that we've done that, we can check out a couple other things here just to make sure we're okay. Output power, And the 130 watts is going to apply to the internal discharge capabilities. And we exit. So now that we've done the power supply setup, charger understands its battery, its regen, we've set the limits. We're going to now set up the battery mode. So there's LiPo and Li-Low. I use both depending on what I'm doing. So here we're going to go to Manage, Edit, Options, and we're going to change the mode from asynchronous to synchronous. And now the charger is going to be ready to use in synchronous mode. And once you do that, don't forget to save your settings, and you'll see a S right there in the corner. And that indicates that it is in synchronous mode. So now that we have the battery connected, you will notice that we're at storage voltage. Both channel 1 and 2 will show the exact same voltage because they're connected in parallel. And the balance data is to the left. So let's go ahead and check our internal resistance. So we're looking at 3.6 pack and the 12.4 with the connection through the leads and your individual battery information. So let's get this thing charged up. And mind you, we are in synchronous mode. And let's get that rolling. We do have our trusty fluke meter here, and we will check the thermals at both the XT150, the solder junction that's connecting the 8 gauge to the 12 gauge, and the 4mm bullets at the charger connection. So let's get this spooled up. We'll start with 40 amps. I'm going to get this thing connected to the input so I could at least see what's coming in and out of the battery. I'll just verbally indicate that. Right now I'm showing 38 amps being drawn from the battery. That's a 40 amp charge. And we're going to check, we're sitting at 86 degrees. And I believe that's pretty close to ambient considering we just started this. So 87, look at the bottom right, which gives you the max reading that was taken. Seems like it's a breeze so far. Let's give it 60 amps. The Andersons would have been smoking hot by now. We got a 60 at least. All right, we're pulling 46.5 from the batteries, charging at 50 amps. Seeing about 94 at the 4mm bullets. Still sitting at 87 at the XT150. And the solder junction is still at 87. So that's what's being drawn out of the batteries right now. 90 degrees at the breaker. It's doing significantly better than we were doing previously. Battery terminals are at a cool 81. Mind you, ambient is 80. These batteries just do not heat up. It's amazing. I would go higher than 50 amps. I can go as high as 70. But I'm fused. So one of the limiting factors here are these fuses that I'm using. So I have these DIN mounted fuse holders. They handle up to 30 amps a pop, but right now I'm using 25 amp fuses. So I'm gonna have to upgrade that before I can start pushing more current out of this setup. And I did set that current limit. So even though if I set it at 70, it's not gonna allow me to go higher than that because I set a 50 amp limit. So I'm gonna have to make even more improvements to the circuit. And once I do that, we'll be able to do a full charge and discharge at 70 amps, which is just over 1C for this battery. It's a little insane. So that's the test for now. Thank you.